Hello everyone and welcome to Physical Science. We are in Unit 5, Section 2, and today we are going to be talking about solubility, whether something dissolves or not. What? Okay, so solubility and concentration. We need to get some definitions out of the way. So solubility is the max amount of a solute, that can be dissolved in a given amount of solvent at a time. Okay, so if you remember, if you have something in a beaker and you have a liquid in here, most of the time solvents will be liquid, but they don't have to be. But in this instance, this will be the solvent. I add something into it, so solvent. This would be the solute, and I remember it by solute means you dissolve. So the thing that is dissolving is going to be the solute. Well, solubility is the max amount of stuff, solute, that you can dissolve in a solvent before it can't take any more. So various substances are going to have different solubilities. Air is a solvent. It can only hold so much moisture or water vapor until it starts falling out. Water can only hold so much salt before, if you keep adding it, it just crystallizes. So, right, substances have different solubilities. We're going to talk about that. The concentration describes the percentage of the solute contained in a whole solution. So a concentration is talking about the percentage of solute in a whole solution. So what percent of the solution is going to be your solute? So how much stuff is dissolved? So when we start talking about solutions and solubility, we can describe our solutions in three separate ways. We can say that the solution is saturated. A saturated solution means that you have dissolved as much solute as you can, but you haven't added extra. So it contains all the solute it can hold at that particular temperature. We're going to talk about how temperature can affect it as well. So at a specific temperature, you've added as much as you possibly can. I want you to envision a glass of water, and you are adding salt. You keep adding salt and adding salt and adding salt. Eventually that salt will not dissolve anymore. If you don't keep going past that point, you have a saturated solution. It's holding as much as it can, but it's not going too far. An unsaturated solution is something that you've added it to, but it can hold more. So you've added just a little bit of salt, but you know you can keep dissolving more into there. So it can hold more solute at the current temperature. So that would be unsaturated. And then the last one, which is my favorite, is super saturated solution. That means that you have added way too much. I like to think of this like Bojangles sweet tea. I think it's super saturated because what they end up doing was they heat up the water, they make the tea's really hot, and they add a bunch of sugar to it. Well, then that sugar dissolves at that warm temperature, but then they cool it down. And when they cool it down, it won't contain, like, it still holds the sugar, but it's holding more than it should. And that's why it's syrupy and sweet. So supersaturated solution was saturated. So when they made the tea and the water was warm, they added the sugar and it was saturated. But then they cooled it because it's iced tea. So now it's holding more than a saturated solution should. Eventually, if you let that sit for too long, if you take Bojangles sweet tea and leave it in your fridge for a really long time, besides making mold, you're also going to end up with sugar crystals falling out because this is unstable. If you heat something up and add a bunch of sugar and then you cool it back down, eventually it'll start crystallizing. This is actually how rock candy is made as well. So these solutions are unstable and a solute can come out. They will start falling out of solution or precipitating out of the solution. So factors affecting solubility, and I'm going to use Bojangles sweet tea as a reference the entire time. Well, when you are making sweet tea, they use factors affecting solubility to their advantage. What they do is they increase the temperature so they can dissolve more sugar. I'm sure that if you've ever gone up north and ordered tea and they don't have iced sweet tea, you've tried to add sugar to it and then stir up the sugar in the cold iced tea, it doesn't work because the lower the temperature, the less the solubility. That's why it just falls to the bottom and you're like, oh God, I just wish I had some sweet tea. Okay, so temperature. So temperature increases. The solubility of most, but not all, but most solutes also increases. So the more you warm it up, the more you can dissolve. So that's why warm tea, you can dissolve the sugar in, but if you ice it first and try to add the sugar afterwards, it's not going to work. If you've never done this, go make some tea. The relationship between temperature and solubility of various solutes is shown on a solubility graph. We can predict how much you can dissolve based on it. So, right, relationships between tea and solubility are shown on a solubility curve or graph. We're going to look at that and I'll show you how to use one of those. So this is a solubility curve or graph, and I know it looks scary, but it's not. In fact, you're only going to look at one line at a time. So don't get intimidated by this whole chart here. Just take it step by step. The first thing I want to draw your attention to is the x-axis. So temperature. This is showing temperature is increasing. Okay, so you're going from temperature of 20 degrees Celsius to 30 to 40 and all the way up to 100 degrees Celsius. On your y-axis, it's showing you how many grams of solute can dissolve in 100 grams of water. So this is just showing you how many grams can actually dissolve into the solution or into the solvent. So 0 grams, 10, 20, 30, 40. So as this goes up, you're seeing that it's increasing the solubility. It's allowing more to dissolve. So when you're trying to figure out what's going on with these, just take it one line at a time. So for instance, number 1, which salt is the least soluble in water at 20 degrees Celsius? So I look at this graph and I try to find the one that is the least soluble in water at 20 degrees Celsius. So I find 20 degrees Celsius. Boop. Which one is the least soluble, meaning dissolved the least into it at 20 degrees Celsius? I go up, bam, that's the least. And then I see what line that is. That is KClO3. Done. That's it. So let's move on to the next one. It says, how many grams of potassium chloride can be dissolved in 200 grams of water at 80 degrees Celsius? So this is getting a little bit more complicated. The first thing I need to see is potassium chloride, and I need to think, what's that formula? Well, potassium is K, and chlorine, or chloride, so KCl. So I need to find the KCl line. Oop, there's KCl. So I am looking at just this line. I don't care about the rest of this graph right now. I'm just looking at this one line. Can be dissolved in 200 grams of water at 80 degrees Celsius. But this one's talking about 100 grams. We'll get there. But let's look at 80 degrees Celsius. Find 80 degrees, okay? And I'm going to trace it up to the potassium chloride line. Okay, and then I'm going to see how much could dissolve at that temperature. So I'm going to trace it over. And I see that it can dissolve 50 grams, but that's in 100 grams of water. So what do I do with that number? Well, if it dissolves 50 grams in 100 grams, and it's asking me about 200 grams, that would be 100 grams, because if this is in 100 grams, 2 times that is 200 grams, so 2 times this amount would give you 100 grams. All right, let's move on to the next one. So it says at 40 degrees Celsius, how much potassium nitrate can be dissolved in 300 grams of water? So I have to think, okay, what is potassium again? That's K. And nitrate is NO3. So I find the line that is KNO3 because that's the one I'm going to be looking at. This one. So I'm not going to care about the rest of these lines. I'm only going to look at this one line for this problem. And it says at 40 degrees Celsius. Notice I'm underlining things as I go so I don't have to keep reading this. So I find 40 degrees Celsius and I trace it up. And I see that that's where 40 degrees Celsius intersects that potassium nitrate line. And then I trace it over. Boop, 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 boop. Well, it's between 40 and 50, but it's not quite halfway. So I'm going to say maybe 40, it's at the 42 line. Oh wait, well, no, it's not. No, it's 40, because I was looking at that one. So it's 40. So it says how much can be dissolved in 300 grams? Well, you have 100 grams. This is 40 can be dissolved in 100 grams. So how much can be dissolved in 300 grams? 3 times that. So 4 times that would be 120 grams. All right. Now, which salt is shown, or which salt shows the least change in solubility from 0 to 100? So which salt is going to show the least change? Which one does not dissolve more or less very much? So I'm going to look at all of my lines now, and I'm going to erase off all the rest of this because it doesn't really matter right now. All I'm looking at is the lines, and I'm going to see which one changes the least. Well, if it changes the least, it means that it's not going up or down fast. And it says from 0 to 100, so we're looking at this whole scale. So which one changes the least? Which one remains the most flat? It is going to be this one, because if you see, this one just kind of does this. It doesn't change very much. It goes from a little less than 40 to about 40. So which one changes the least? Sodium chloride. At 30 degrees Celsius, and I'm underlining so I don't have to reread, and at 36 degrees Celsius, 90 grams of sodium nitrate, and I write sodium nitrate. If you don't remember what nitrate is, remember consult your polyatomic ions on your reference sheet. So at 30 degrees Celsius, 90 grams of sodium nitrate is dissolved in 100 grams of water. So it's exactly the same as what's going on this chart. It says, is the solution saturated, unsaturated, or supersaturated? Ooh, so I have to think. Saturated means it's dissolved as much as it can, but not too much. So that means the line, because this is the saturated line. Unsaturated means it could dissolve more. So you'd fall below whatever line you're talking about. Or supersaturated. If you were above the line, you would be considered supersaturated. So let's look at this with sodium nitrate. So I'm going to find my sodium nitrate line. Bam, right there. And then I am going to see, so it says at 30 degrees Celsius. So I'm going to trace up to my sodium nitrate line at 30 degrees Celsius, and it's right here. And it says 90 grams are dissolved. Trace it over. It's right on that line, or really close to that line. So if it's right on that line, we call that saturated. If it were above the line, we'd call it supersaturated because it has more than it should. And if it had fallen below the line, we would have called that unsaturated because it could hold more. All right, just a few more examples. So at what temperature will 50 grams of KCl dissolve in 100 grams of water? So we're looking at just what's normal on this chart. So let's find our KCl line, which is right here. And it says at what temperature will 50 grams dissolve? Well, the grams is over on this side, so I'm going to trace 50 grams over to the line. So this is when 50 grams can dissolve. What temperature is that? That is 80 degrees Celsius. What compound shows a decrease in solubility from 0 to 100? So which one of these lines shows it decreasing? Well, the only one that shows a decrease from about 90 to about 8 is this line. So I find the name of this line, NH3. All right, so this one says, which salts have the same solubility at 58 degrees Celsius? So I find 58 degrees Celsius, so it's just less than 60. I'm going to trace it up, and I'm going to see which two lines pass through that point. So at 68 degrees Celsius, both potassium chloride and ammonium chloride can dissolve the same amount. So that would be potassium chloride and ammonium chloride. All right, which salt is the most soluble at 10 degrees Celsius? So I find 10 degrees Celsius, boop, 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 and I see which one is the most soluble, so I trace it up and I see which one is the highest soluble, or how much contains the most solute, And I see way up here that Ki, potassium iodide, is the most soluble at 10 degrees Celsius. All right, last one. Which salt is least soluble at 90 degrees Celsius? So I find 90 degrees Celsius. Let me switch my colors. And see which one is least soluble. Boop, that one. What is that one? I trace it up and I see it is NH3. So if you just analyze one line at a time and don't get overwhelmed by the fact that there are a lot of lines, because they're only going to ask you to look at one line at a time. And so this is showing you a bunch of data, but you don't have to use it all at once. You guys got this. Have a great day.